look at managing the design, setting up a schedule, and estimating the costs. So let's look at our syllabus quickly and see where we're at. So in terms of the course contents, we have covered a lot of this material here. So we have arrived at managing the design, project goals, and tasks. We have talked about patents a little bit, and then these three subjects we'll get in the next remaining portion of the course. To review, we have to, you as students have to, and as design members of your groups have to submit these 6 items, and you have most of you have submitted the project application. And so now let's kind of look at it up here, the managing the design project goals and tasks are going to be associated with your project proposal. So everything I'm going to be talking about now is going into your design proposal. And this is chapter 5 in the textbook. So let's take a look at it. So in planning and managing design process, as we'll just read this here, we draw on the methods of approach project management. So let's say you're a manager now. So many of the things that you'll be seeing here is what you're going to see your boss doing when you get your job. So the reasons that this is important is we need to have tools to ensure, in addition to meeting design objectives, that the design is completed on time and on budget. And we have some trouble with some of you groups here because you guys some of those groups are just not turning things in on time. So let's first of all start with the definition of a project. Basically, a project is a quantifiable piece of work with a defined end and start. And work that meets this kind of definition are construction projects, consulting studies, and design projects. Work that does not meet this definition are things that are in continuous service, or what we call line functions. Now, line functions are examples of those are operating a factory which continues every day, maintaining telecommunications systems which goes all the time, and unfortunately lecturing at a university also seems to be that way as well sometimes. Other attributes associated with a project, though, are these. Their output is a low volume, something unique that you're doing. There are measurable objectives, and it uses a limited set of resources, people, materials, and equipment. And also, the work is often complex, uncertain, and urgent, and that's what you've been experiencing in this class. The uncertainty, the complexity, and the urgency. That's because it's not the same thing as getting a job at McDonald's, for example, where you don't have any uncertainty and nothing is complex, at least after the first couple weeks. Now let's take a look at what you might find in a company that you would be joining. You have a project manager who's working under purchasing, marketing, manufacturing, and these are that project manager's bosses, essentially. And underneath that person is people that work in the electrical area, mechanical area, and support areas. So what we're going to be talking about is you filling in a position here, for example, but then also writing documentation that a project manager would be familiar with. Okay, so most of your design work is down here. Maybe in a group of 3, a person is doing this, a person is doing this, and then the third person is sort of managing or at least filling out the forms for that particular situation. Now, let's take a project, and this project I'm going to show you is a lawnmower. This is really amazingly simple, but what we're going to do is we're going to have a project that basically determines the rotation per minute of a lawnmower. Okay, a RPM measurement device, and the R stands for RPM and the MD stands for measurement device. Okay, so this example, I'm not going to spend too much time on it because it's designed in using the old technology So let's say that you have a spark plug. What we're going to do is we're going to shape the pulse and then divide by 10 and count it, and then we'll be able to display. Well, we can do this a lot easier now, but this is the gist of the project. The details are not important because I'm looking at managing this project, and so we look at setting up a schedule. So let's say, and I want you to kind of remember these dates in April, May, and June because they're going to appear in some other slides here. But basically, what we're looking at is, for example, as you are doing right now in 4810, you're kind of finalizing your system design. All right. So I guess this is a good point to say, where are we talking about 4810 here? We're really projecting ourselves into 4820 next semester. So what we're doing is we're setting up the schedule for what you're going to do next time in the next course. So here you've got some design issues for the main board, the power supply, the control panel and packaging, integrate and test. So this would be probably something that you would be doing in 4810, I guess, in that respect. But then you'd be doing the circuit design. You would be doing the final design revisions and essentially producing the 3 prototypes in the 4820. So 4810 for these activities and 4820 certainly for this last one. Okay, so this kind of shows you how things will work. I said that this would be next semester, but I can see the way that's written out. These designs and things really should be done in the 4810. But anyway, so you have a schedule that includes essentially 4810 and 4820 here, but in the real world. Now, personnel, you're going to need some people to do circuit design, packaging, and technician support. Okay, and of course, you're going to do your own work on that. And then you have a certain amount of budget to buy some materials to set up a prototype. And this is not the materials necessary to do mass production, but this is the materials to do a project. So small amount of money, kind of uncertainty, and complexity. Okay, so this is an example of a project. So here's a detailed work description for this RMD. And it has a system design, main board design, power supply, etc., etc., etc. All right, and we'll keep on going to the next slide here. And then we have personnel that's assigned to these things. Now, of course, in your group of 2 or 3, you've got 3 people to work with. But in general, in a company, you would have a senior engineer. Look at the bottom here: design engineer, packaging engineer, lab technician, drawing office, and prototype shop. Some of you are already working in companies where you have to deal with things like that. So what they do here is for those elements that need to be done here, the main board, the power supply, the packaging supply design. Now, of course, they're designing it here for actually making it into a something for the future. They have to be very careful. So for example, DE is the design engineer. Notice the design engineer is really taking off here in almost every element here. And then you have the technician over here, and they all essentially eat up time. Okay, so 3 weeks for this, 4 weeks for this, 1 week for this, 3 weeks for this, and then each of these people are assigned to days. Okay, so believe it or not, this is the kind of thing that we're going to be asking you to detail, probably more along the line of this column here, but this gives you an idea of how a project would actually be aligned. Now, what would you actually produce in your proposal? In your proposal, you're going to essentially quantify this information into something called a network diagram, although I think it might appear as a Gantt chart, so just hang on, as we'll show you. So we're saying that we have weeks here: week 0 work, week 3, week 7, week 8, week 9.5, and 11. And so we're going to be doing system design here, and then we're going to be doing 3 things in parallel here: integrate and test here, finalize. Okay, so this is essentially these 3 here for 4810, and then these last 2 or 3 here is the 4820 essentially. Okay, and then overall you have project management looking at everything. Now let's see what we can how we can quantify this. Well, one way of doing this is drawing something called a network diagram, okay? And so we have 8 tasks that we showed over there. And let's kind of go back here. And so those 8 tasks are these 1, 2, 3, 4, 5, 6, 7, 8. Okay, so these 8 tasks are labeled 1, 2, 3, 4, 5, 6, 7. And 8 was the one on the bottom. I guess I missed that one on the previous slide, although I just threw a number 8 in there. And so what this is actually showing you is a way of quantifying this with boxes. And we use this key down here. So this position here is indicating the task number. This is indicating the amount of elapsed time. This is indicating the end week, and this is indicating the start week. Okay, so for example, I've used this project management box here as a key, but actually, because it goes throughout the whole thing here, but it actually shows you all 5 of these things here, including the title. So if I look at power supply, for example, this one here says that this is task number 3. It takes 1 week of time, and it starts in week 3, and it ends in week number 4. So now I want you to pay attention to this blue line that I'm showing you here, because this is indicating a critical path. A critical path is the following. This is deemed to be more critical than the 2 below it because it takes the most amount of time. It takes 4 weeks. These only take 1 week and 3 weeks, so they have some slack time essentially associated with that. And notice that in the slack time slot here, you have 3 and 1, but you have nothing here for this item here. So this is the one that's really critical, because if this takes more time, that lengthens the whole time of the project. While if these 2 took more, a small amount of time, it wouldn't make any difference at all. So the blue line is really indicating what we call something called a critical path, and I'll point that critical path out also in the Gantt chart coming up. So this is the explanation of that. So I've kind of gone through this, and you can read this explaining critical path and select time. Now, something else here that I didn't talk about is something called precedence. So, for example, if I go down to this diagram, I cannot do this box until these 3 are done. So these 3 here are preceding this element here, and so there's some precedence here that I can't start this one until I got these 3 done here. Or I certainly can't do the finalize until I've done the integration and tests. So that's what they're talking about here. Now, how you might manifest this in your project is this. This is a bar chart. This has the same information as this diagram here. All right. So notice I have 1, 3, 1, 1, 1. All right. And if you look at this diagram here, now you have 1, 3, 1, 1, 1. And project management is continuing here. So this also is indicating what we're doing. So if I was to draw a critical path in here, let's actually start doing something here. Let's kind of change the blue, because that's what we asked to do earlier. And so I'm going to pick out a little bit brighter blue here if I can. Let's take a look here and grab a nice blue here. There we go. So here's our critical path here. So this would go through this, and then through this one, and then through this one, and this one. You see how this works here? So starting off on this side, on the left, this is my critical path. Now, I'm going to supply you a sample Gantt chart. This is called a Gantt chart. All right. And I'll supply you one that's done by another student project, and you can use that information. It's all set up on Excel. So that will be. So when we talk about setting up a network analysis, such as this or this, go ahead and use the Gantt chart. That might be a little bit easier to use. Now, the idea of precedence and these other terminologies that we talked about can also be seen in these 3 diagrams, A, B, and C. So A is indicating that this is the amount of time it takes to do that task. However, you have some slack time because apparently there's something else going on that can go up to this point over here. So and on the second diagram here, we're indicating some precedence. So here's task 1, and task 1 must be done. It must precede task 3. And so this red arrow, including this this triangle here, is indicating this precedence. And then it's indicating that task 2 and task 3 must occur at these 2 points here, preceding this task over here. And by the way, notice the slack time here. So this example here on slack time, okay, let's kind of put a circle around this, is actually manifested more as an example right there. There's where your slack time appears, because this one could go additional time because task 2 is actually forming the critical path here, okay? And so here's an example of that here, okay, like that. So in C, we're actually doing the critical path, and I'm not going to draw all this here, but if I compare these boxes with the ones down in dark gray here, they are the 3 elements here that would be the critical path, although this one here seems to be a little bit too long here. So maybe it's a slightly different example, but you get the idea. Now, so this is a required component in your proposal. Another thing that's required in your proposal is something called a precedence matrix, all right? So what this does is it's a matrix of all the activities that you're involved with, and then this chart will indicate what precedes what, all right? So for example, let's take a look at this chart here. So here I have A, B, C, and D, and these are specifications. This is for a circuit breaker test equipment project, and the details are not important, but these are the 4 specifications. And then we have 7 parts here. We have the motors, reducer, CB operating mechanism, etc., etc., etc. Now, on this side here, we have something called a predecessor level, which is saying the following. To do electric motor, we must obey the rated voltage, which is specification A, and we also must have the 2 and 3 done before. So it's indicating that 2 and 3 here, okay, 2 and 3 here must be done, if I use that little notation here, must be done before you do number 1, okay, for this example. Why it's that way, I don't know, but this is the example. So that's hard to visualize, this information here. So why don't we just take a look at drawing a matrix that would indicate this. So let's remember, electric motor requires A, 2, and 3. So here's your precedence matrix, and this is very easy to do. All you do is you put your specifications A, B, C, D, and then list your, typically you list them in the order, in the time order that it should be designed. So it looks like 7, 3, 1, 5, 4, and 6. Okay, and if I go to 1 that I was looking at, notice that it required specification A, and it had, with a high amount of requirement, and also a high amount of requirement for number 3. Let's just check that to make sure I've got doing the right one here. Yeah, 2 and 3. Okay, so both 2 and 3. It turns out 2 is only mediumly need to be done before, and H is highly, okay? So these 3 circles here are indicating the 3 elements here, A, B, and C, okay? So that's pretty messy, so I don't want to leave it like that, if you don't mind, so I'm just going to go erase that. And so in any other example here, so for example, the inductor requires A, B, and C, and so if we come over here, we can see that the inductor requires A, B, and C here, and very highly. So this is a precedence matrix, and you can set this up any way that you want to, probably just in a word processor, and it only takes a few minutes to work this out. So this is some of the tools. The network diagram and the precedence matrix are required in your proposal. And then the other thing is you have to estimate what your costs are. So this is going to be an interesting discussion. And that takes us to section 0.5.5 in the textbook. By the way, we're almost done with the textbook. So that's good because we're almost done with the course. So it looks like, as we specified earlier, that the budget materials costs are going to be about $1,750. And I think it's rounded off to be $1,800 here on the next slide. Okay, so let's just write that down here, just so you don't get confused. And then it needs to rent some equipment for $500, so the total cost is $2,250. Okay, so let's look at the table 5.1 here. And let's take a look at that. That's 5.4, so I guess 5.1, I don't have that diagram, but so this will be the information that we have. All right, so let's take a look at where the costs are involved. Now, in your case, the supplies and materials are the only thing that you typically are concerned with as students. All right, but because you have no overhead. The overhead is this part. All right. For example, if somebody was paying you to do this job, you would be part of the overhead. If you were using a lab shop and some other facilities, that'd be part of the overhead, as well as using outside student services, outside services. All right, so this is the overhead. Now, it turns out the overhead is quite significant in its costs, and you'll be kind of shocked, I think, to see what it is. So let's take a look at the student costs here. All right, and the student costs, I think I'm going to write this out in red, actually. So let's, before I go to the next slide here, because I'm already peering at the next slide, and I can see that it looks like I'm going to be looking at a red section here. So let's put this down here, red. Student cost. All right, so let's go to that next slide. So here it is. Okay, the student costs are going to be the supplies and the rental costs that you had. It totals to be $2,300 if I use the $1,800 for the supplies. All right. Now this is the only part that you're concerned about in your proposal. You need to indicate this cost. However, it's not the real cost. If you were operating in a real world, you'd be paying yourself, right? You would be maybe the design engineer, okay? But you've got, and so that would be you. So here you are. You're going to pay yourself a certain amount of salary here. The salary here is indicated by a number that you multiply by weeks, okay? And you have your boss is a senior engineer, and you have a packaging engineer, and you have all these other services. Well, look at this. It's taking up all of these costs, okay? So 20 plus 15 plus 15 is 50, and then 50 times something looks like 50 times 60 is giving my 300 number. So these numbers here are relative because they're all based upon an earlier time, 1980s probably. So I'm not too worried about the numbers. But oh, excuse me, I'm miscalculating this. So I need to go vertically here, not horizontally. The 300, 100, 200, and 500, and 1200, that's set. Okay. So these costs here are then added up to be 29. These costs here are added up to be 12. These costs here, 24, 11, and 26. Now, here's the rate. I need to multiply those by a certain rate, whatever that turns out to be, and it's different for the senior engineer and the design engineer as well as these other components. So the results aren't too important except the final cost. The final cost that we're going to come down here, which I'll put in blue now. So I'm going to switch back to that blue color. Fortunately, it gives me a recent here, which is really nice. And so these costs here are going to be the cost of the overhead, including your salary. Okay, just remember, your salary is overhead. So let's take a look. How much does this end up being cost? So that's shown on the next slide here. So it turns out that the costs of these is going to be 58, all right, 5,800, all right. If I wrote it in blue, it'd be probably a little bit more impressive. So let's kind of draw this out in blue here. All right. And I can't erase them apparently. So there's 5,800. Now that's my overhead. Your cost as a student, all right, or just the supplies and the rental is here. So now you're going to get an eye-opening experience here that, yeah, sure, you can do things on your own. It only costs you $2,200. Actually, it's $2,300 on that last page here because this is actually $1,800, right, as I mentioned. Okay. But the actual cost of it is you have to add the $2,300 to a whopping $58,000. All right. And so this kind of shows you the difference. Okay. So up here, this is the job that you're going to be getting. You are going to be part of the personnel costs. Okay. You are going to inflict a lot of money costs here. A student project down here is only going to inflict this amount of costs. So in your student proposal, you are only going to have this factor, but in reality, you can't ignore this. And if you object to this, and you say, well, I don't think we should be paying that much money for this, well, your same thing as saying, well, you better go get a job and you can work for free, because that's what you're saying. So you're going to have to get over that idea, all right? And because you have to earn money. Money comes from someplace, and the someplace that it comes from is overhead. So that kind of concludes what I wanted to talk to you about in terms of managing the project and determining your costs. And in the next section, this is a critical section that we're coming up the next time that we meet. And I have discussed this just a bit earlier. We are going to discuss how you're going to incorporate all these ideas into your project. So you're going to have a project that is going to have an introduction section, including a thesis statement, and then the next sections following it are your requirement specification, system design, cost, and schedule. So this is essentially what we've been talking about here. So number 4 was today's objective, okay? So this is what we talked about today. And you've already done, or you're working on the system design, you've got part of that done, you've done the requirement specification, you've got your literature search, your appendix is not too hard, and your introduction is also done, started in the Google Forms, right? In your Google form, you started working on this. Okay, so that gave you your introduction. That's why we spent so much of the semester working on this idea, so you have a nice thesis, and we'll explain some of these other processes, including some of these concepts that are shown on this diagram, the next time we meet. So until then, have a great day, and we will talk to you soon.